This is Advanced Algebra 1, Topic 3, Section 1, dealing with the difference between a relation and function. So some definitions in here, and we'll try to relate it back to what we've already learned in Topic 2, in the equation of a line. So a relation is just a set of ordered pairs. It can be random. Ordered pairs, x coordinate, y coordinate, whatever that set is, we call that a relationship, a relation. If it has special properties, then it can be a function. In those special properties, a function is a relation in which for every x value, there's one and only one y value. And so I'm going to bring in another piece of paper here and show you what I mean by that. So we've been graphing lines, and if we look at the graph of a line, for every x value, this x value has a y value. This x value has a y value. This x value has a y value. For every x value, there's only one y value. And indicate a situation where that wouldn't be true would be if we look at that vertical line. In that vertical line, this x value has this y value, this y value, this y value, this y value. All the y values are the same, or they are different, but each one has a y value. And so therefore this isn't a function. This is simply a relation. So one of the ways we tell the difference between a function and a relation is what we call the vertical line test. So if I imagine an infinite number of vertical lines going through this graph, it only crosses this line once. Therefore, that line is a function. But if my graph is say a parabola that opens this way, and we'll study those later on, as I look at the vertical line test, this vertical line, there's two y values. So this x value has two y values. This x value has two y values. Therefore, that's not a function. A parabola that opens up or down, like this, that is a function, because every x value has one and only one y value. We're going to study absolute value eventually. And if we look at the graph of absolute value, the graph of the absolute value is a V. And every x value has only one y value. So that would be considered a function. So one of the ways, if we're looking at it graphically, one of the ways to test whether or not something is a function is to use what we call the vertical line test. If I'm looking at a set of ordered pairs, and this is different from this, but if I'm looking at a set of ordered pairs, like the point 2, 3, the point 3, 4, the point 4, 5, and the point 2, 6, okay, that set of ordered pairs would not be a function, because this x value 2 has two different y values. And so therefore, that's not a function. If I get rid of this last point, the 2, 6, now it is a function, because every x value has a different y value. Okay. And like if I could have also had the 0.55, that would still be a function. And if we ever question whether or not it's a function, we can always plot those points. 2, 3, wherever that is, 3, 4, wherever that is, 4, 5, wherever that is, 5, 5, wherever that is, and then imagine the vertical lines going through there. It only crosses once. If I add that point in 2, 6, now that vertical line goes through 2 points. Not a function. Okay. When we talk about functions, we like to talk about the domain and the range. Okay, so the domain is the set of x values, and the range is the set of y values. It's that simple. If I look at a equation of a line, the set of x values are the domain. The numbers I get when I plug in that x, that's the range. Okay. For example, if I give you a set of ordered pairs in a table, okay, we would say the domain, and D for domain obviously, is 3, 5, 7, 9, 11. And I just listed 3, 5, 7, 9, 11. The range is the set of y values, which in this case is 1, 2, 3, 4, 5. And that's really all there is to it. The x values are the domain, the y values are the range. And notice that this is a function, that every x value has a y value. And there's no x's repeated up here. Because if they were, that would mean we didn't have a function. Okay. Okay. So then what the book wants us to do is they want us to analyze these situations and determine what the domain is and what the range is of the function. And we're doing that. The domain determines the value in the range. So like here I'm talking about filling a swimming pool. So the domain would be the set of time, okay? Because however much time has passed, that's how much water is going to be in the pool. So the domain is going to be how much time has passed, and the range is going to be how much water is in the pool. And it doesn't go the other way. It doesn't make sense the other way around. It doesn't make sense to say that the range or the amount of water in the pool determines how much time has passed. That doesn't make any sense, does it? So it's how much time has passed determines how much water's in the pool. So a reasonable domain here would be the time, based on the time, and we would say it's 0 to t minutes until the pool is full. Okay. So how much time passes determines how much water's in the pool. And the range then is going to be how much water's in the pool, and we start out at 0 gallons, and it's full at 10,000 gallons. And it's filling at a rate of 10 T gallons per minute, or 10 T gallons, because they gave us the rate is 10 gallons per minute. So at 5 minutes, it would be 50 gallons. At 100 minutes, it would be 1,000 gallons. Okay. And then we talk about whether or not this is a continuous domain or a discrete domain. And this one is a continuous domain. The reason it's continuous is because I can ask, how much water's in the pool at 2.5 minutes, or how much water's in the pool at 123.4 minutes. Okay, so it's not just, I just can't plug in 1, 2, 3, 4, 5. I can plug in any fraction or decimal between those. And so therefore it's a continuous domain. Okay. Another example, restaurant needs to order chairs for its tables, and one table can accommodate 4 chairs. So it's the, what's going to determine what? Is it the number of chairs are going to determine how many tables I have, or are how many tables I have going to determine how many chairs I need? Okay, and it's that one. The number of tables I have is going to determine how many chairs I need. So a reasonable domain would be 0 to the number of tables needing chairs. And the range then would be every table needs 4 chairs. So it would be 0 to 4t, where t is the number of tables needing chairs. And I'm not going to say that we need, 3.5 tables, or that we have 3.5 tables, and so therefore we're going to need 14 chairs, right? It's either going to be 3 tables or 4 tables and 12 chairs or 16 chairs, okay? So we say that this domain is discrete because it's not going to include any fractions. I'm not going to have a half of a table or a fourth of a table, anything like that. So difference between continuous and discrete domain. Continuous domain, fractions and decimals are included. Discrete domain, it has to be whole numbers. Okay. So then we want to go one step further, and we want to define a function that's one-to-one. Okay. So going back to my graphs here, I use a vertical line test to determine whether or not it's a function. And we said this is a function. And then I use the horizontal line test to determine whether or not it's one-to-one. And what we mean by one-to-one is that no 2 elements in the domain map to the same element in the range. So for every y value, there's one and only one x value. So this function is also one-to-one because as I imagine horizontal lines going through my graph here, it only crosses the graph once. Therefore, that is a function that is one-to-one. This is not a function, so we don't care whether or not it's one-to-one. This is not a function, so we don't care whether or not it's one-to-one. This was a function, so we do care whether or not it's one-to-one. And it is not, because as I imagine those horizontal lines going through, they cross twice, right? This y value, whatever it is, this y value has 2 x values. And so therefore it is a function, but it is not one-to-one. Our absolute value down here, it was a function because it passes the vertical line test, but it's not one-to-one because it doesn't pass the horizontal line test. Okay, so on paper, sorry. So another way they like to list a set of numbers is like this, where -2 gets mapped into 5, 3 gets mapped into 6 and 7, 4 gets mapped into 8. And because 3 is getting mapped into 2 different things, 2 different y values. So if I were to plot these points, I'd have -2, 5 up here somewhere. I'd have 3 at 6 and 3 at 7 and then 4 at 8. So this right here says, not a function. And if it's not a function, it's not one-to-one. Okay. So we don't even consider one-to-one if it's not a function. To make this a function, I could throw in another value here and say that's what gets mapped into 7, rather than 3 getting mapped into both 6 and 7, and then that would make it a function, and then we could see if it's one-to-one after that. You have the equation of a line, y equals -2x plus 3. So let's see, 1, 2, 3, then rise -2, run 1, rise -2, run 1. So we get this line when we graph it, and that line passes the vertical line test, right? So it is a function. And then if we look at the horizontal line test, the horizontal line's going through here, it is one-to-one. Okay. We can look at the graph of a parabola. It's a quadratic equation, and as I said, we will be graphing these eventually. They have a vertex, and then they go out from there. Okay, so might look something like this. And this is a quadratic equation. Its graph is a parabola. And as you can tell, it's a function because it passes the vertical line test. It only crosses that each one once. Okay, so it is a function. Then we look at the horizontal line test to determine whether or not it's one-to-one. And boom, 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 it crosses more than once. Therefore, it is not one-to-one. Okay. And this whole idea of being one-to-one or not being one-to-one has to do with the inverse operation. If a function is one-to-one, then it has an inverse. If it's not, then it doesn't have an inverse. So that's about all there is on that. Have the online homework and quiz, just like always.